In this video, we're going to have a look at the horizontal translation of an exponential function. We already know what the influence of the a, the b, and the q value is on an exponential function. Now let's go and have a look at what the p value indicates. From your previous knowledge on graphs, you should know that any value added to x will cause a horizontal translation left or right. And this movement will be in the opposite direction of what you would expect. So when the p-value is positive, the graph will move in the negative direction. And if the p-value is negative, the graph will move in the positive direction to the right. Notice that the horizontal asymptote does not move when a p-value is added. It does, however, also move up and down when a q value is added to translate the graph vertically. So the p value moves the graph horizontally left and right, and the q value moves it vertically. So let's summarize the exponential function. Firstly, the b value shows us whether the graph will be increasing or decreasing. A b value between 0 and 1 shows a decreasing graph, and a b value bigger than 1 an increasing graph. Then the exponential function can undergo three transformations. The p-value indicates the horizontal translation for any type of graph. We know that a positive p-value will move the function to the left and a negative p-value to the right. The q-value indicates the vertical translation. A q-value that is positive moves the graph up, and a negative q value moves it down. The q value also indicates the horizontal asymptote of the function, which lies at y is equal to q. Finally, the sign of the a value indicates whether the graph has been reflected around the x-axis. A positive a value indicates no reflection, and then the graph lies above its asymptote. A negative a value indicates that the reflection has taken place, and now the function lies below its asymptote. Next, let's go and sketch an exponential function. Sketch the following function and indicate the intercepts with the axis and the asymptote. When I start off getting a rough idea of what the sketch will look like, the first value I will have a look at is the b value. This is bigger than 1, and that tells me that it will be an increasing function. Next, I look at the p value, which is a plus 1, and this tells me that the whole function moves 1 unit to the left. Next, I look at the sign of the a value, and in this case that is negative, and this indicates that the whole function will now reflect around the x-axis. And finally, the plus 1 at the end indicates that this whole graph is now translated up 1 unit and has a horizontal asymptote at y is equal to 1. Now I can see that there will be an x and a y-intercept that I need to go and calculate. For the y-intercept, we change the x value in the equation to 0. And now we have minus 3 to the power of 1 plus 1, which will give us a y value of minus 2 and an intercept at 0 minus 2. To calculate the x-intercept, I will change the y value in the equation to 0. And now I will take the minus 3 to the power of x plus 1 and add it on the left. Now I need to get the base numbers the same to solve x in the exponent. To do this, you need to know your exponents and know that 3 to the power of 0 is 1. And because the base numbers are now the same, we can say that the exponent on the left is equal to the exponent on the right, which means that x is equal to minus 1, and the x-intercept is at minus 1 and 0. So in the final sketch, I start indicating the asymptote at y is equal to 1, and now I draw my decreasing function and indicates the intercept of -1 and 0 and the y-intercept of 0 and -2.